Hello, this is Mr. White. We're on Chapter 13. This is Lesson 2, Cycles of Matter. My Planet Diary, Canaries and Coal. Have you ever stopped to listen to a bird sing? If you were a coal miner in the early 1900s, your life may have depended on it. Sometimes miners stumbled upon pockets of carbon monoxide, a toxic, odorless gas that makes it difficult for the body to get enough oxygen. Without fresh air circulating in the mine shafts, the miners would fall asleep and eventually die. To prevent this disaster from happening, canaries were used to monitor the air quality. A singing canary indicated that all was well. If the canary stopped singing and died, the miners knew that they needed to quickly leave the mine. What processes are involved in the water cycle? Recycling is important for ecosystems because matter is limited. To understand how matter cycles through an ecosystem, you need to know a few terms that describe the structure of matter. Matter is made up of tiny particles, called atoms. Two or more atoms that are joined and act as a unit make up a molecule. For example, a water molecule consists of two hydrogen atoms and one oxygen atom. Water is essential for life. The water cycle is the continuous process by which water moves from Earth's surface to the atmosphere and back. The process of evaporation, condensation, and precipitation make up the water cycle. Evaporation. How does water from the ground get into the air? The process by which molecules of liquid water absorb energy and change to a gas is called evaporation. The energy for evaporation comes from the heat of the sun. In the water cycle, liquid water evaporates from oceans, lakes, and other sources and forms water vapor, a gas, in the atmosphere. Smaller amounts of water also evaporate from living things. Plants release water vapor from their leaves. You release water in your waste and water vapor when you exhale. Condensation. As water vapor rises higher in the atmosphere, it cools down. The cooled vapor then turns back into tiny droplets of liquid water. The process by which a gas changes to a liquid is called condensation. The water droplets collect around dust particles and form clouds. Precipitation. As more water vapor condenses, the drops of water in the clouds grow larger. Eventually, the heavy drops fall to the earth as precipitation: rain, snow, sleet, or hail. Precipitation may fall into oceans, lakes, or rivers. The precipitation that falls on land may soak into the soil and become groundwater, or run off the land, flowing back into a river or ocean. How are the carbon and oxygen cycles related? Carbon and oxygen are also necessary for life. Carbon is an essential building block in the bodies of living things. For example, carbon is a major component of bones and the proteins that build muscles. And most organisms use oxygen for their life processes. In ecosystems, the process by which carbon and oxygen are recycled are linked. Producers, consumers, and decomposers all play roles in the recycling of carbon and oxygen. The carbon cycle. Most producers take in carbon dioxide gas from the air during food making or photosynthesis. They use carbon from the carbon dioxide to make food, carbon-containing molecules such as sugars and starches. As consumers eat producers, they take in the carbon-containing molecules. Both producers and consumers then break down the food to obtain energy. As the food is broken down, producers and consumers release carbon dioxide and water into the environment. When producers and consumers die, decomposers break down the remains and return carbon molecules to the soil. Some decomposers also release carbon dioxide into air. The oxygen cycle. Look at Figure 2. Like carbon, oxygen cycles through ecosystems. Producers release oxygen as a result of photosynthesis. Most organisms take in oxygen from the air or in water and use it to carry out their life processes. Human impact. Human activities also affect the levels of carbon and oxygen in the atmosphere. When humans burn oil and other plant-based fuels, carbon dioxide is released into the atmosphere. Carbon dioxide levels can also rise when humans clear forests for lumber, fuel, and farmland. Increasing levels of carbon dioxide are a major factor in global warming. As you know, Producers take in carbon dioxide during photosynthesis. When trees are removed from the ecosystem, there are fewer producers to absorb carbon dioxide. There is an even greater effect if trees are burned down to clear a forest. When trees are burned down, additional carbon dioxide is released during the burning process. Carbon dioxide in the atmosphere. Some human activities release carbon compounds into the air. Animals and plants break down sugars and release carbon dioxide. Plants take in carbon dioxide and use carbon to make sugar molecules. Plants produce oxygen, which is then taken in by the animals. When organisms die, decomposers return carbon compounds to the soil and release carbon dioxide into the air. Carbon compounds are taken up by plants. How does nitrogen cycle through the ecosystem? Like carbon, nitrogen is one of the necessary building blocks that make up living things. For example, in addition to carbon, nitrogen is also an important component of proteins. In the nitrogen cycle, nitrogen moves from the air into the soil, into living things, and back into the air or soil. Since the air around you is about 78% nitrogen gas, you might think that it would be easy for living things to obtain nitrogen. However, most organisms cannot use nitrogen gas. Nitrogen gas is called free nitrogen because it is not combined with any other kind of atom. Nitrogen fixation. Most organisms can use nitrogen only after it has been fixed or combined with other elements to form nitrogen-containing compounds. The process of changing free nitrogen into a usable form of nitrogen, as shown in Figure 4, is called nitrogen fixation. Most nitrogen fixation is performed by certain kinds of bacteria. These bacteria live in bumps called noodles on the roots of legumes. These plants include clover, beans, peas, alfalfa, peanuts, and some trees. The relationship between the bacteria and the legumes is an example of mutualism. Both the bacteria and the plant benefit from this relationship. The bacteria feed on the plant's sugars, and the plants are supplied with nitrogen in a usable form. Return of nitrogen to the environment. Once nitrogen is fixed, producers can use it to build proteins and other complex compounds. Nitrogen can cycle from the soil to producers and then to consumers many times. At some point, however, bacteria break down the nitrogen compounds completely. These bacteria then release free nitrogen back into the air, causing the cycle to continue. Free nitrogen in the air. Soil bacteria releases some free nitrogen into the air. Consumers eat nitrogen compounds in plants. Plants use simple nitrogen compounds to make proteins and other complex compounds. Decomposers return simple nitrogen compounds to the soil.